Hey everyone, welcome back, ready for another deep dive. Today we're taking a look at AI-generated art. More specifically, those amazing diffusion models. You know, the ones that can make pictures from just a few words. It's incredible what they can do. Yeah, it's really mind-blowing how far this technology has come. I mean, you can type in almost anything and get a pretty decent image back.
Yeah.
But have you ever noticed how sometimes the results can be kind of hit or miss?
Oh, absolutely. Like even with the same prompts, you can get some pictures that are just stunning and then others that are, well, let's just say they need a bit more work, right?
Yeah, exactly. It all comes down to the starting point, you see. The way these diffusion models work is they begin with random noise. Then they refine it step by step based on the text prompt.
So it's like taking a blurry image and slowly bringing it into focus.
Yeah, that's a good way to put it.
Mm-hmm.
But here's where it gets really interesting, okay? The research we're looking at today, they found that not all noise is created equal.
What? Like some noise is better than others?
Yep. Some noise is, you could say, golden. It just leads to way better results. And that's what this paper, Golden Noise for Diffusion Models, a learning framework, is all about.
Okay, so we've got AI making art from noise, and now we've got special golden noise that makes the art even better. I gotta admit, I'm intrigued. But before we get into the how, can we talk about the why for a minute? Like, why is this golden noise such a big deal?
Well, think about it. Up until now, trying to find that golden noise was a real pain. You basically had to generate tons and tons of random noise, see what the AI came up with, and hope for a masterpiece. It was so time-consuming, not to mention computationally expensive.
Yeah, I can see how that would be a problem. It's almost like you're throwing paint at a canvas randomly and just hoping for the best.
That's a great analogy. And that's precisely why this research is so groundbreaking. They've essentially found a way to take that random splatter and turn it into a controlled brushstroke, giving you way more precision and control over the AI-generated images.
So they've figured out how to teach an AI to find the gold in random noise. How do they do that?
Well, they came up with a really clever three-stage workflow. First, they gather a huge amount of data. They use this technique called read-to-noise sampling to create pairs of regular noise and its corresponding golden noise, all based on specific text prompts.
So it's kind of like they're showing the AI examples of what good noise looks like. Right?
Exactly. But they didn't stop there. They actually used another AI model, a really sophisticated one, to filter out any low-quality noise pairs.
So they're using AI to curate the training data for another AI. That's wild. But doesn't that raise some questions about bias? Like, is this AI critic going to be too picky?
That's a really good point, and it's something we can definitely dig into more later. It's a big question about the role of randomness in art in general.
Yeah, like if you're controlling every little detail, is it still truly art?
Right, where does the human element come in? These are all things we can explore more as we go. But for now, let's get back to this three-stage workflow.
Okay, so we've got our carefully curated dataset of noise pairs. What happens in stage 2?
That's where they train a neural network, which they've named NPNet. Basically, they feed NPNet all these noise pairs, and it learns the relationship between the regular noise, the text prompt, and its golden counterpart.
So NPNet is learning the secret recipe for turning regular noise into golden noise.
You got it. And the way it does this is actually pretty ingenious. It uses two key components. One is called singular value prediction, and the other is residual prediction.
Okay, those sound pretty technical. Can you break those down for us?
Sure. So singular value prediction, it's kind of like a mathematical trick. It helps NPNet find the hidden similarities between regular and golden noise.
Wait, so you're saying there are patterns even in random noise?
That's exactly what they found. It's actually quite fascinating. There's a surprising amount of predictability even in what we think of as random.
Okay, my mind is officially blown. Can't wait to hear more about this second component, residual prediction, and what kind of amazing images this golden noise can actually create.
We're just getting started, trust me. There's so much more to unpack, and you won't want to miss it.
Sounds good. Let's take a quick break and then we'll dive into those details. Okay, so we left off talking about how this NPNet thing learns to find golden noise, but I'm still a little fuzzy on how it actually works in practice.
Well, you know how sometimes the best way to describe something complex is to simplify it?
Yeah, like instead of listing every single detail, you just give the overall impression.
Exactly. And that's kind of what NPNet's first component does. Instead of getting bogged down in the nitty-gritty of the noise itself, it looks for those key features that make it golden.
Okay, I'm trying to picture it. Is it like instead of describing a sound wave with all its frequencies, you just say, it sounds like a trumpet playing a high note?
That's a great analogy. And in this case, those trumpet and high note descriptors are something called singular vectors.
Singular vectors, those were those ingredients of the noise.
You got it. Each singular vector contributes something to the overall pattern of the noise. And what NPNet does is it figures out how to tweak the amounts of each ingredient to create that perfect golden blend.
So it's like adjusting a recipe to get the perfect flavor profile.
Exactly. Those adjustments, that's what we call singular value prediction.
Ah, okay, I'm starting to see the picture. So that's how NPNet finds the golden qualities in the noise. But didn't you say there was a second component too? Something about residual prediction?
Oh, right. That's where the text prompt really comes into play. NPNet has this built-in text encoder. It's like a mini AI that understands language.
So it reads the text prompt and figures out what kind of image we're going for.
Exactly. Let's say your prompt is something like a photorealistic cat wearing a tiny hat. That text encoder will extract key information like cat, hat, photorealistic, and it'll use that information to fine-tune the golden noise even further.
So it's like NPNet is saying, okay, we need to emphasize the fluffiness, the tiny hat, the realistic details.
Precisely. And that fine-tuning, that's what we call residual prediction.
It's like adding the final touches to a painting, right? The highlights on the fur, the twinkle in the cat's eye.
Perfect analogy. It's all about bringing out those details that make the image truly special.
And I bet those results are pretty impressive, huh?
They are. They tested this whole system on a bunch of popular AI art models, like Stable Diffusion, DALL-E 2, those kinds of things. And the images generated with NPNet consistently got higher ratings for quality.
Wow, so not only are the images better, but it's also faster and more efficient because you're not wasting time sifting through tons of random noise. This is amazing. But let's step back for a second. Why should people even care about better AI-generated art? Is this just about making prettier pictures?
That's a great question. And honestly, it's something people are still debating. On one hand, yeah, it could be seen as purely aesthetic, just a way to create more visually appealing images.
But I feel like there's got to be more to it than that, right?
I think so too. I mean, this research has some really interesting implications for the future of art and creativity.
Okay, I'm listening.
Think about it this way. Up until now, AI art has mostly been about mimicking human styles. But with this golden noise stuff, we're moving into a whole new realm where AI can actually enhance and augment human creativity.
So you're saying this could be a tool for artists, not just a replacement for them?
Exactly. It's like a collaboration. Artists could use these noise prompts to guide the creative process, explore new styles, push the boundaries of their own imagination.
Now that's exciting, but we also have to be careful, right? AI art brings up a lot of ethical questions about copyright ownership, even what it means to be an artist.
Absolutely. Those are all valid concerns. As this technology becomes more powerful, we need to have serious discussions about its impact.
Yeah, we can't just ignore the potential downsides.
Exactly. It's a balancing act.
Well, I think we've covered the main points of this golden noise research. We've seen how it works, why it matters, and even glimpsed some of its future potential.
It's a really fascinating field, and it's changing so rapidly.
I can't wait to see what they come up with next. But for now, I think it's time to move on to part 3 of our deep dive. Okay, so we've talked about how this golden noise thing works and all that, and we even touched on some of the bigger implications for AI and art, but you know what I'm still kind of stuck on?
What's that?
Well, we keep saying this golden noise makes the AI art better, but what does better even mean here, you know?
Oh, that's a good question. Yeah, it's really at the heart of what makes this whole thing so interesting, right?
Yeah.
Like, I mean, on the one hand, better could just mean images that are, well, just prettier to look at, like more technically skilled, you know?
Yeah.
More like what we've always thought of as good art.
Right, like with sharper details, richer colors, things like that.
Exactly. Stuff that makes the image really stand out.
Mm-hmm.
But there's another layer to it, isn't there? Remember how we were talking about randomness being such a key part of art?
Yeah, that like real art needs that bit of unpredictability, a little bit of chaos.
Right, right. So now we've got this AI that can actually look at those random elements and kind of like predict them, finding these little bits that make the results more like what we want. It really makes you wonder, you know?
About what?
So if we can engineer good randomness, does that take away from the artistic value in some way?
Whoa, that's a really good point. Like,
Yeah.
if you remove the human element, the surprise, does it become less about art and more about just optimizing things?
Yeah, yeah. And it's something that artists and critics are really struggling with right now. Like, some people say that by getting rid of chance, we're kind of cleaning up creativity too much, turning it into something predictable.
Right.
But then others see it as a tool, a way to help human expression be even better.
So, like, instead of AI replacing artists, it becomes more like their partner.
Yeah, exactly. Like, imagine if artists could use these noise prompts to come up with new ideas and explore new styles. They could really push the boundaries of what they can do.
I like that, yeah.
Think about it this way. You know how a photographer picks a certain lens, or a painter chooses their brushes?
Yeah.
Well, this is kind of like that, isn't it?
And like golden noise is just another tool they can use.
Right. It helps them navigate all these possibilities that AI-generated art gives them.
Yeah, I see what you mean.
It's not about AI versus humans. It's about how they can work together.
That's a good way to put it.
And this is just the beginning. We're still figuring out how creative AI can be.
Oh, I've definitely got a lot to think about now. I don't think I'll look at AI-generated art the same way again.
I know what you mean.
So to wrap things up, what's the one thing you really hope our listeners take away from all this?
I guess it would be to remember that AI is a tool, a really powerful tool, but still a tool. It's up to us, the humans, to decide how it's used, to make sure it helps us be more creative, not less.
Well said. And as always, we hope you'll keep exploring and asking questions and just diving deep into all the amazing things out there.
That's what it's all about.
Thanks for joining us for another deep dive.
See you next time.